consulting. Um, meetings being recorded, that's fine. So I'll give an overview of the company. I won't spend too much time on organization and general capabilities. I'll pretty quickly shift to some of our specific projects that we've done recently. I think those are more interesting and support kind of our vision and our objective of being a leader in the advanced air mobility arena by providing strategy consulting, concept development, and implementation support. So on the title slide, you see some graphics, just some pretty pictures about some of the various capabilities that we bring to the table. But again, I'm going to go in and talk to you a little bit more generally. Please do interrupt with any questions. I've only got, you can kind of see on the left-hand side, I've only got about 15 slides. I've kept it fairly brief so that there's plenty of room for questions and discussions, both during the briefing and afterwards, where we can talk about whatever you'd like to talk about. All right, I'm just gonna conserve bandwidth a little bit here and turn my video off. So who is Crown? Crown Consulting is a small business. We were founded in 1989, so we've been around for a little while, but not forever. We are based in Arlington, Virginia. That's kind of my home base when I go into the office, but we have presence pretty much nationwide. So for example, we have a pretty large workforce at NASA Ames Research Center, which is in the San Francisco Bay Area out in California. We've got a significant presence in Southern California. And again, all in various other places around the country also. And when I say small business, there's businesses that are even smaller than us, but we are at approximately 200 people in our company. So what do we do? And kind of this is how we're organized into our business unit. So I kind of live organizationally over on that left-hand side, which is science and research. That includes all of our NASA research. It lives there. We have a programs and engineering group. That's primarily where we work for the FAA in a variety of different arenas. And then finally, the integration and infrastructure business unit. That is much more applied, hands-on field engineering. And it's one of the things that I think makes us a little bit different than other small businesses is we kind of take it all the way from concepts and strategy to developing those technologies, running programs, all the way to fielding them, building avionics equipment, rack systems for air-ground communications, building towers and other facilities like those. So having the breadth of capabilities helps us because, for example, when we do concept and strategy, sort of on the front end side of the life cycle, it helps to have experience and knowledge of how this stuff actually gets used in the field, how it has to be maintained and built. It really helps you think through and stay away from impractical solutions. Make sure you're working on stuff that can actually be implemented out in the field. I won't spend a ton of time on this slide, but just I think at least some of you will recognize some of the names, some of the folks that we have working at Crown in our leadership team. And I think one of the things that distinguishes us, and you don't have to read through all this right now, but a lot of us have significant experience with NASA and with the FAA as well. So we've been on the side of the government. We understand what NASA, what FAA is looking for, what's important to them. Now that we're on sort of this side of the fence, it helps to have that understanding when we provide our support and do our studies. Who do we work for and with? Lots of people. Some of you are on this slide somewhere. But you see FAA, you see NASA, those are ones that you're certainly familiar with, but you see a lot of different companies, you see some different universities, and it's just to show you the breadth of the scope that we have. We are very, very happy and willing to bring partners with us to support our clients when that makes the most sense. As a small business especially, we don't have all the capabilities, but we do have the capability to find the right people and the right partners. And that's part of the message behind the slide that you see here. All right, so let me now start talking about some of the specific efforts that we've done, specifically in the advanced air mobility and urban air mobility space. And so you see a bunch of the studies and efforts listed here. The first one, UAM market study, this was back in 2018 and helped kickstart this whole initiative from NASA. So what they really wanted to do is look at this market, look at urban air mobility, eventually advanced air mobility, and really understand, is this worth us being NASA, worth us investing in? Is there really a market promise here and potential? And so that's what they asked us to look at. There was a parallel study done by Booz Allen Hamilton so that NASA could get two different opinions. Both of those studies are publicly available. You can get those right off of the NASA website. We then took another step kind of in level of detail and helped NASA co-author their urban air mobility operational concept description. Now note the acronym. This was the OPSCON. You have also seen and probably are very familiar with concepts of operation. Not exactly the same thing, right? From a systems engineering perspective, those are different documents for slightly different purposes. So we've actually participated in both of those, but this particular bullet is referring to the OPSCON. We then, based on the market study and the OPSCON, NASA asked us to develop what is referred to as a minimum viable product, MVP. This concept of an MVP is borrowed from other industries. Silicon Valley, for example, uses this with software often, where they'll put out a product that works. It does have a certain functionality. It provides benefits to the consumers who buy it, but it's not the end state. It's sort of a waypoint on the path towards a more fully fleshed product. And so the idea here was, the market studies, both ours and the one done by Booz Allen, said, yes, there's a market here, but for particular business cases and use cases, it's going to take a while. You know, you're not going to see this realized until 2030 or beyond for most of the use cases. So what NASA said is, hey, is there an MVP that could be viable sooner than that? That could be a stepping stone towards full maturation. And in fact, that's the study that we did. The bottom line was we identified medical package delivery as the MVP use case. And it turned out, so we did that study in 2019, and it turned out that later in 2019, independent of the work we did, that is in fact the first use case that started to be realized, particularly in North Carolina in conjunction with Matternet and UPS, where they started delivering medical packages around the campus of WakeMed. And so that was a nice validation for our work, which was independent of what they were doing in industry, but they arrived at the same conclusion and in fact are doing it today as well. Another thing NASA asked us to look at was, okay, part of the market's going to depend on people actually using these vehicles. So what are the passenger acceptance ramifications and considerations? So we did a study looking at that, looking at passenger acceptance criteria and what those might look like. We then pivoted and used that to do a phase 1 NASA SBIR to start looking at actually conducting flight simulator experiments to see what kind of vibrations, what kind of loads and G-forces, et cetera, were tolerable. So all of this to try to jumpstart this market, this industry, to make it viable and real. We've also supported a lot of simulation and flight tests, which is kind of in the middle of the slide there. and you can see what kind of things we're doing there. So for example, what was started with is looking at existing helicopter routes and seeing if those could be adapted by eVTOL, and sure enough, they certainly can as a first step. You don't want to be limited to those existing routes in the future, but it's a nice starting point because those are already published and approved. Some of the other work that we did, this gap analysis, I think is pretty interesting. So the idea there is to say, hey, FAA has been working for a long time on quote unquote next gen. You guys have all heard about next gen. There's lots and lots of different programs and projects and technologies and initiatives that comprise next gen. But what comes after that? And what does it take to achieve the vision out in 2035 and out to 2045 compared to where next gen left off? And are there gaps in that space? And so we did a systematic analysis of that, which included a lot of interviews with the leading NASA people in various aspects of that. The next one is talking about a high density vertiport automation concept of operations. I'm actually going to spend more time on that one and go into a little bit more depth on that. So I'm going to skip it for the purpose of this slide. We recently completed a study of autonomous air cargo. This was also for NASA. This was a market study as well for that particular use case, identifying all the economic and regulatory and technology aspects, the challenges that are associated with all of those to realize that particular market. And we're also supporting implementation of AAM in a variety of places, specifically North Carolina, Ohio, and New York. And I've got a few slides on those coming up as well. Let me just pause and take a breath there in case anyone has any initial questions or comments before I move on. Okay, hearing none. So I mentioned North Carolina. We were part of their team for the FAA's Integrated Pilot Program, IPP, which is now completed. We are supporting them on the follow-up program, which is called Beyond also. That's not on the slide, but that is something we're active with as well. And I mentioned, in fact, some of the things that we've been doing. Some of it is helping other companies like UPS support operations within North Carolina. We've helped them interface with the FAA, and we've kind of been the coordinating partner between other participants, and you see them listed there. North Carolina is very interested in NASA's UTM concept for small drones, and what they have been trying to do is put into place a statewide UTM operation, specifically for emergency service response. So that they're not necessarily beholden to a commercial provider for that they would instead have that operated on their behalf just for those kind of operations. That is not in place yet, but it's in discussion with the FAA, and we're helping facilitate that as well. And I mentioned some of the operations that are happening in North Carolina. We've been active in that. We've done some of the safety case analysis and helped get the necessary waivers for those operations, which is it's on the leading edge of these kinds of operations. And then finally, this is now probably about 18 months ago, maybe even 2 years, we helped enable the first public US flight of an autonomous air taxi. That's the picture that you see on the lower right there. That's the EHang vehicle, their 216. And the gentleman, the smiling gentleman there is Tom Edwards, who was one of the Crown leaders that I mentioned on one of the previous slides. Tom actually helped facilitate and make the arrangements and coordination, but he also served as what's called the air boss, which is kind of the ultimate authority for those kind of operations, who says, yes, this can proceed, or no, it can't, or something happened, bring it back down, all of those kind of command and control responsibilities. So that was a very interesting milestone. For Ohio, we've actually recently completed a study which looked at the economic impact of AAM in that particular state, statewide. And so we examined a lot of different use cases, over 20 of them, but focusing a lot on where those operations might happen in coincidence with some of the existing infrastructure, like the existing highway system. So how could this kind of mode of transportation, AAM, complement and perhaps in some cases supplement that surface-based mode? And so there was a variety of efforts there. There was also a lot of surveys involved with that, because there's a lot of different industry and participants that are involved that would have to be involved in making AAM a reality. So we got input from all of them as well. Another place that we support is up in New York. So there's an organization up there that runs things called NewAir. I don't think I've got it spelled out here. That is Northeast UAS Airspace Integration Research. And they operate that FAA UAS test site up there in New York. We have helped them with a variety of things. Like I said, the vertiport automation system work that I'm going to talk more about was actually led by NewAir under contract to NASA, but we were the lead participant in that, supporting that work. Again, I'll describe that more. We've helped them with their efforts with the FAA and NASA, writing proposals, executing some of them. The third one down there, so the Grand Challenge, which now is known as the National Campaign. We participated in part of that on behalf of NewAir, and we've helped them with various aspects of systems engineering and portfolio management. And that's ongoing work as well. Okay, so I promised I would go into a little bit more depth on this project to develop a AAM high density vertiport concept of operation. So I want to point out a few things on this slide. First of all, the prime contractor again was NewAir. That's the first logo you see there up at the top. They reside and report to Oneida County. That's the circle that's next to NewAir. And then we had additional partners, including Mosaic ATM, 5 Alpha, which is a very, very knowledgeable expert by the name of Rex Alexander, who has tremendous depth of expertise and knowledge in this area. Boeing and Deloitte were also on the team, as well as GAMA, the General Aircraft Manufacturers Association, and HAI, Helicopter Association International. So nice big team, really valuable expertise that came through from all of them. And what we were doing in total was producing these 4 documents. I'm going to focus on the ConOps, which is the middle, second from the left there. But the work started with a trade study. Deloitte led that trade study. Then Crown led the concept of operations, as well as co-led the software architecture and requirements. That was co-led with Mosaic ATM. And then we also led the MBSE implementation along with Deloitte. And so we were pretty active throughout this project. Today, I'm going to focus on the ConOps. So how did we do that? So first of all, we started by developing a set of use cases. And there's different use cases that align with different levels of maturity of UAM. And those are the UML 1 through 4 that you see on the left-hand side. And these are not exhaustive in terms of the use cases, just to give you a sense of what kind of things we were looking at. We did a pretty significant literature review, pretty standard thing to do in a circumstance like this. We did a lot of interviews. So, all the different kinds of organizations that would be involved, and you see the types of folks there listed on the upper right. And then finally, we used the trade study that Deloitte did, as well as incorporate NASA feedback. And that's what helped us produce this concept of operations. And what that document looks like is here on slide 12. So the document was organized in accordance with an existing standard that's been published by IEEE. You can see the reference down in the footnote. And we used that as a starting point and then adapted it as needed for our particular purposes. But you see the main headings, introduction, current state, et cetera, and then some of the subsections beyond there. It's pretty much what you would expect. We kind of talk about how things stand now in 2 and the changes that people are looking for in 3. The meat of it is really in number 4, the future state concept of operations, but that's helped illustrated by the operational scenarios. Then finally, there's a summary of the impacts if you're able to go to this state of operations. And then a brief analysis, which is again more or less a summary of how things would look. Within that main section, number 4, the future state, you can see the blow up on the right-hand side there of the different elements of the vertiport that we thought were important. So I'm not going to read those all to you, but I hope that gives you a flavor for the kinds of aspects that we considered for this concept of operations. So one of the things that let me put this in the slideshow mode here because this slide builds. Everyone's still seeing the slides okay, right?
Yes.
Okay. So let me click through here. So you see this nice pretty picture. This was one of the products that we developed. This is a so-called OV1, operational viewpoint diagram. This is adapted from enterprise architecture principles. And you see a lot of different elements on here. And I'm going to try to walk you through these fairly quickly. So first of all, it's sort of in the lower left-hand side of the graphic, you see a couple of cylinders. And those are the outer cylinder, the transparent red one is what we call the vertiport operations area. And then the inner one is the vertiport volume. And so that space around this kind of facility, the vertiport, where you start to have operations coming in and out. And so the outer cylinder is kind of the outer boundary, as you would expect. And then the inner one is where it's sort of protected airspace, where no one should be in there except people who are actually the vehicles that are taking off or landing from this particular vertiport. Now, backing up to sort of the big picture, you see the kind of cloud icons in the upper left, and those are representative of different providers of service for UAM, PSUs. So that terminology comes from the NASA and FAA concept of operations for UAM. And those are entities, PSUs, that, as their name implies, provide air traffic services rather than the FAA providing them directly. The PSUs provide those to the different operators and vehicles serving AAM missions. The Vertiport Operational Control Center. So that's kind of the hub, the brains of what's going on within the facility, kind of looking at graphics, big screens of the incoming and outgoing traffic, what's going on the surface, and what's happening within the region of the vertiport, potentially including other vertiports if they're in relatively close proximity. Okay. The vehicles themselves would be communicated with and in some sense controlled by a fleet operational control center. So the vertiport isn't actively managing those vehicles, especially not on their way to and from the vertiport. That would be done by the operators themselves through these fleet operational control centers. Okay, so I mentioned PSUs before. There's also other providers or stakeholders or commercial entities involved. One of those are SDSPs. SDSP is Supplemental Data Service Provider. So for example, think of them as one commonly cited example is a weather provider. So especially for AAM where local micro weather is very important, that would be perhaps a service that is being provided by a third party to PSUs or directly to vehicle operators. All right. Let me move on. So then the next, we have a second OV1, and this one focuses more on sort of the vertiport itself. So the other one was kind of a big picture of the system that's operating. And then this one is more close to the vertiport itself. So you see the green and the red kind of swooshy paths. So the green ones are the nominal flight paths of the aircraft trajectory. So what we're depicting here is consistent with the FAA and NASA concepts of operations. Think of these as the flight corridors or tubes, if you want to call them that, that the AAM aircraft would be operating within. Oh, and by the way, the red ones are where flights have been rerouted. So for example, if there was a conflict or an anticipated conflict and an aircraft had to deviate, that's what the red is depicting. Okay, so what the slide builds through is kind of the activities that would happen as operations proceed. So first of all, of course, you would have pre-flight activities before anything happens in terms of flights taking off or landing. So you see the various kinds of activities, including filings of flight plans, the coordination between the ground and these PSUs, and then that culminates with the fleet operator actually saying, okay, you're good to go, you're authorized, and the flight is dispatched. Okay, so that then takes you to taxi and takeoff, which again involves coordination between the PSU and the vertiport, and both of them coordinating with the flight crew and the aircraft itself. So then you transition to climbing out and cruising. That part of the operation is, fairly similar to traditional operations, except that you're coordinating with the PSU more than with traditional air traffic control or air traffic management. Then finally, on the other end of your trajectory, you kind of do the same kind of things in reverse for your approach, where now you've entered those two cylinders I talked about, the VPV and the VOA, VOA first. And so as you enter those volumes of airspace, you do certain things, or different actors do different things. And that's what we're talking about with the approach steps. Then finally, you go ahead and land, taxi, and deplane. And that's where the action's happening on the vertiport surface. Okay, so that's a very, very fast walkthrough, but I wanted to, again, keep it fairly brief so that there was plenty of time for questions. And again, I can answer questions about Crown, about the vertiport project, about our other projects. And as I offered to Peng when we talked about this, I happen to have experience in a few different varieties of the aerospace profession. So I've worked as a civil servant at NASA. I've worked for a not-for-profit company. I've worked for a small for-profit company. I'd be happy to talk about that or any other sort of career-related aspects. So let me stop talking and give people a chance to chime in.
Thank you, Shahab. Very exciting and insightful presentation. I learned a lot on the UAM or AAM vertiport side, also on the terminal airspace side, a lot of new things for me as well. So now we are open for questions. I'm also going to stop recording. So if you have any questions you want to discuss with Shahab, please go ahead.